y squared z is equal to 0 means what? Either y equal to 0 or z equal to 0, obviously. So either y equals 0 or z equal to 0, then 2x yz equal to 0, so for sure y equal to 0. Then 2x yz equal to 0, so y is equal to 0. Okay, right here. So x equal to 0, this follows that y equals 0, and y equals 0 right here, then x y squared equal to 0, so z is equal to 0 as well. And you got z is equal to 0 as well, so all x 0, y 0, z is 0. All x, y is equal to 0 is going to contradict with here. So x squared, y squared plus z squared equal to 4. Cannot happen. Okay? And this is not a solution. Not good. Let me cheat a little. I mean, not good. Try y equal to 0 and see what happens. Y equals 0, so y equals 0 right here, so obvious x is going to be equal to 0 as well. Okay? X equals 0, y equals 0, so z is going to be equal to 0. Y equals 0, so what here? And then x equal to 0. Okay? And x equals 0 right here. And z is going to be equal to 0 as well. So it's not a good choice. Similarly, if z equal to 0, and I claim the same thing happened because x and z are playing the same role in the game. You see, symmetrical with x and z. Whatever happened to x happened to z. You can check it out. Z equal to 0, z equals 0, so x equal to 0. Okay, and x equals 0 right here. 2x, y, z equals 0, so y is also equal to 0. And we cannot have all x, y, z equal to 0 at the same time because we know that x squared plus y squared plus z squared got to be equal to 4. So they cannot be equal to 0. None of those values are going to be 0. So all x, y, z are going to be non-zeros. Okay? So if all x, y, z are going to be non-zero, we're okay to do division. And you know that lambda is always non-zero. So this is the little techniques that I usually try first. After testing the 0 to solve, we're going to choose a pair of equation and we're going to do a division. The reason for that is I can cancel out the lambda. So let me choose the first two equations. Y squared z over 2x yz going to be equal to lambda 2x over lambda 2y. Okay, so on the left hand side, cancel out the z, we cancel out one of the y, I got y over 2x going to be equal to x over y. Another word, y squared is equal to 2x squared. I am doing cross multiplication. Okay, y squared multiply both sides by 2x, multiply both sides by y. I have this. Something useful coming out. Okay, now choose another pair and get rid of lambda again. How about the last two? Okay, 2xyz and then xy squared. I got 2xyz over xy squared gonna be equal to lambda 2y over lambda 2z. And of course, simplify both sides again. On the left hand side, let me write in here. We have what? X cancel out, y cancel out, so 2z over y is equal to cancel lambda. So this is y over z. Again, cross multiplication, I got y squared is equal to 2z squared. And I'm glad that that's good enough for me to solve because I have the third equation. The fourth equation, x squared plus y squared equal to 4. So let me rewrite it up here. I just need some room to write, guys, so let's erase something. I got x squared plus y squared plus z squared equal to 4, right? So y squared is equal to 2x squared, y squared equal to 2z squared. So let's solve for x squared. X squared gonna be y squared over 2, and z squared is also y squared over 2. Look at here, y squared over 2 plus y squared over 2 equal to 4. Now it's only one variable y, right? What I'm doing right here, substitution. Okay, so a half is 1 plus 1 is 2, so 2y squared equal to 4. Y squared equal to 2, so y is plus or minus square root of 2. we have to solve for x and z as well. So you know that y squared equals to 2, right? So x squared equal to y squared over 2 is 2 over 2 equal to 1. And same thing, z squared is y squared over 2. 2 over 2 is 1 again. Okay? So x is plus or minus 1, and then z is plus or minus 1. Okay? So x, y, z could be plus or minus 1, plus or minus square root 2, and then plus or minus 1. And you know how many solutions we may have in here? 8 of them. Right. 1 square root of 2, 1 square root of 2, negative 1. Okay? 1 negative square root of 2, 1 negative square root of 2, negative 1, negative 1 square root of 2, 1 negative square root of 2, negative 1, so forth and so on. Okay? So you count them. It's going to be 8 of those total. Question now is, which point's going to give you the max, which one going to give you the mean? So look back to the function. I know it doesn't matter what, y squared is always equal to 2, right? Y could be plus or minus square root of 2, but I know that what? Y squared is always equal to 2. X could be 1 or negative 1. Z could be 1 or negative 1. X is plus or minus 1. Z is plus or minus 1. So x times z be equal to plus or minus 1. Why? Z. Sorry, guys. Z. Right? Could be 1 times negative 1 or negative 1 times 1. Or 1 times 1 or negative 1 times negative 1. You can have what? Plus 1 or negative 1. Okay? So y squared is 2, x times z is plus or minus 1, together f of x, y, z, which is x, y squared z, will be plus or minus 2. 2 times plus or minus 1. No, plus or minus 2. So you have what? Maximum is at 2. So max of f, x, y, z equal to 2. The mean of f, x, y, z equal to negative 2. Okay? So which value is going to give you the max at 2? I know for sure that y is always plus or minus square root of 2, right? And you got 2 if the product is equal to 1, so you got 1 comma plus minus root 2 comma 1, or negative 1 plus or minus square root of 2 comma negative 1. Okay? See how many solutions you have right here? 4. 1, root 2, 1, negative root 2 and 1. And then same thing for negative right here. You got plus or minus root 2 in the middle. So 2 solutions. And any of those 4 points, you have a maximum of f, x, y, z equal to 2. And the other one, x and z will not be the same sign anymore. It's going to be an alternative. So what? 1 plus or minus root 2, negative 1. Right? So 1 times negative 1 is negative 1 times root 2 squared, so 2, so it's going to be negative 2. The other one is going to be negative 1 for x and positive 1 for z. Okay, those are all total 8 points. 4 points going to be maximum, and then the other 4 points going to be the minimum. You see, it's not easy, all right? Especially when you deal with algebra. You see, I'm not saying that the techniques I'm using right here are going to work for all the problems, because I know for sure, especially not going to work for all. You have trig functions, you have exponential function. It's going to be on your homework. We'll work it out, and then you have difficulty with the algebra skill, you shoot me a question, email me, okay? I'll try to help you with. But anyway, somehow you see some common idea, techniques that you see that we try to put on the problem. First of all, you have a function f, find a function g, set gradient of f equal to lambda gradient of g, along with the constraint, which is the g function equal to constant. You set up system of equation, okay? And usually I will carefully check for the special case that those variables x, y, z could be equal to 0 or not, okay? Sometimes equal to 0, like the first example, it works. Some other time may not be equal to 0, depends on the problem, okay? And after that, you see the way I did, I got to do division, okay? Take an equation, divide by another equation. One more time, it may not work for all the problems. I gotta emphasize that, but it's worth trying, okay? And the reason why we're doing that, because we try to get rid of lambda. When you divide two equations with lambda on top, lambda on bottom, lambda are gonna be canceled out. then you have one less variable to worry about, because all you really care is x, y, z, you see. The answer, you don't have lambda. So, and then you get rid of lambda, you can solve, hopefully. All right? And as I say one more time, please practice. We're on count 3 already, right? So practice is the key. And any question, ask. I'm going to stop the video clip right here. Thank you for watching, everyone. Any question, one more time, please ask. Okay? Have a good day, everyone.